Hello everybody. I don't know who's gonna be watching my channel on YouTube. I'm gonna be talking about are all the even numbers sums of primes and how the Collet conjecture. You can also use it. You can also use the Collet conjecture to prove uh that all even numbers are primes. Because I was able to prove some stuff about the Collet conjecture, but they might be helpful to prove even numbers are the sums of primes are the sums of primes. So like you also have to write the proof, and we're not gonna be teaching math. We're just gonna be talking about problems and stuff. Um so you can go into like other channels and learn about they teach math. So they teach math like geometry, legitimate math, uh legitimate math doctrine. But yeah, because mostly the Collet conjecture is kind of interesting, but almost it's about the same principle because everything has to end in one. And some even numbers are going to be ending in one because, you know, you divide by two. But let me just not get into it right now. And twin primes. Yeah, twin primes, some of the properties. I think I got some cherries for some people over there, uh yeah, if you're like interested in twin primes, I haven't particularly since I don't really read like manuscripts about this stuff, so I don't know if it's out there. So let me see here. um let's see. The sums, the even numbers are the sums of primes. So basically you gotta have two primes equals an even number. Actually, it goes deeper than just primes. It's just mostly two odd numbers will equal an even number legitimately legitimately all the time. So like if you divide two things evenly, there's going to be two odd numbers 100%. Like if you just divide by two, it's going to be two odd numbers divided by, so that means like for example 7 plus 7, that kind of cuts it into the middle, so it's going to equal an even number. So if you add it up, it's going to equal an even number. uh Maybe because uh, one. So like for example, like if you take 7 and you take away 1, it gives you an even number. So if you take 1 from 7 on both sides, you're gonna have two even numbers. So and whenever two even numbers add up, it's gonna give you an even number legitimately. So that'll be like, for example, that'll be like 6 plus 6 will equal 12. That's going to give you an even number. So Collet's conjecture also kind of reflects this into the how how even numbers are the sums of primes. But this takes it into way more to a higher level. Because actually stating that prime that like all even numbers are gonna be the sums of primes like infinitely. Is it infinitely? Well, the majority of primes, like prime number series, are in the infinite category. So uh in my previous video, I think I was able to prove the Collet conjecture. It is kind of infinitely a thing because it goes on for infinite. It does go infinitely, but but it's mostly true for even numbers. See my video, you might want to get into watching. See, so mostly for even numbers. So this would be kind of true that in some way that could help, but I don't have the conjecture or the proof to you can sort of write the proof in the conjecture, but I'm not gonna go into it that much because we're not gonna go into another mainstream. We're just gonna talk about this. And also, like, if you're trying to raise pitchforks and torches into where I live and trying to break into stuff, just I don't keep manuscripts. I just mostly do this, and whatever happens goes online. So if I get embarrassed or everybody's embarrassed about it, or you trying to make fun of me or something, yeah, that's pretty much what you're gonna go. Pretty much. So legitimately, okay, so we can see pretty much that it is gonna be true, but most of it, let me see here. Since I don't have a script right now, I'm just gonna go with one of the primary solutions is the prime gaps on this for the sums of primes, and primarily because of the prime gaps. It kind of makes it it is a true statement, but as the prime gaps increases, so like a prime gap would be like right a prime gap would be something like 5 and 7. You have a gap between 3. I mean, you have a gap between 6 right here would be considered because it's an even number and it's a prime gap. So 5 is prime, 7 is prime. Like 2 and 3 doesn't have a prime gap, so that's 0. That's 0 there. So it goes from 0 and then to 1 because 3 is prime, 5 is prime, so that's 1. And then it goes 1 because 5 and 7 are prime. 5 and 7 are prime, so that's 1. So 7 and the next prime, that's 11. So you go from 1. See, you go from 0, 1, and then 1, and then you go 1, 2, 3, and that's 11. So you also try to see if it will match up the Fibonacci sequence, because you have pretty much 2, 3 zeros, right? So then you have 1, and then 1 plus 0 is just gonna be 1. So, and then you have another 1, which 1 plus, that's gonna be 2. So 3. So 3 would be something like 2 plus 1. So that's gonna give you a 3 right here. So it kind of does fit into it, the Fibonacci sequence. So you have one prime gap here. So, and then let me see here. So let's not lose my place here. So you got 7. Yeah, you got 7 to 11, and that's a gap of 3. So you go back to 1. So it was a nice theory, but you could probably somewhat put the Fibonacci sequence there, but then that would be so that was a 3. I should have probably wrote down the Fibonacci sequence. Let me see if I can do it right here. It's not really what I want to get into, but yeah, Fibonacci sequence would uh be like 0, 1, and 1. Let me see. 1, yeah, 1 plus 1, and 2. Okay, 0 plus 1 is 1. Okay, so 1 plus 2. I mean, no, 1 plus 1. I really forgot how to Fibonacci sequence. But let me just look it up. Probably I can uh, see where I could probably go. But there is a certain order. So you got it's a certain order that you could probably try to fit into it. So to me, it kind of reminds me of the Fibonacci sequence. Um, you got 7, 11, and then you got 1 again. And then you have 1, 2, 3 again, and then 1, 1, 2, 3, and then 1. But it's mostly gonna keep increasing. The prime gaps increase. So let me see here until 11 comes into play exactly. So one of the properties is that prime gaps increase depending on the multiple of the next prime. So see here, so 11, so if you keep up with the multiples of 11, so it'll be like 11, 22, 33 comes back over here, and this is where the multiple of 11 comes in. Also it's gonna add another prime gap in between the twin primes. See, now you start going into twin primes, and then the twin primes are going to start showing up whenever you start highlighting the primes. So it's going to keep adding prime gaps because of the whole property of multiples of primes. So then so a multiple of 13, a 13 would be 26, which is gonna show up right here again. So you got another one here, so it's gonna keep adding another. So it's gonna keep adding like prime gaps. I didn't quite show it because usually I don't have the patience, but that will probably be like a content for more content for another video. Once I start going more regular, doing it more regularly, and I just don't know. I just start doing this again. So yeah. So like so you can probably put these two things are gonna be showing up again, but definitely like right here as well. So if you have like see one like 2 right here, this is one of the problems I have with the sums of 2 primes equaling an even number is that 2 is not included. So because 1 needs to be prime in order for 2 to be included. So if you have like 1 plus 1 will equal a prime number, but that's just the essence of just adding uh adding odd numbers. And as the multiples increase, the prime usually the prime gaps will make it really difficult for the sums of primes, but it is going to be absolutely infinitely true. There's no, because it's not really like depending. The problem is you can get prime gaps. I mean I forgot. um the problem is that the sums of primes are not depending on some numerical sequence, but mostly what I was trying to do is it depends on the multiples of prime. So how many natural numbers are going to be divisible by primes, and it's going to keep adding to the prime gaps. So as the prime gaps get bigger, the uh, um the sums of uh the sums of the sums of primes that will equal even numbers are going to get substantially um fewer, if you can believe it, actually. But it will go into infinite. But as the infinity grows, uh so is the mm, there's gonna be there's gonna be a difference of it. It's just I don't have like a supercomputer or anything like that. So what I'm trying to explain is the prime gaps increase, right? So it's gonna start showing like the sums of the evens, right? But the prime gaps are gonna keep increasing. So and you can only add primes to it. So like for example, right here, 24 is gonna keep going. See here right now we just got even numbers that could see, because even also one of the things that makes it true is that because the even numbers are even, you can just do this. See right here, add a bunch of twos. So if you keep adding a bunch of twos to the sum, because two is prime because it's only divisible by 1 and 2. So if 2 is prime, then this particular number series will make every even number regardless of the position also of the prime gaps. So that is like the one of the primary cherries that I think it is absolutely true, is it regardless whatever number you get to a billion and it's even, you can just add a bunch of twos and it will make the sums of primes a true statement regardless of the, but you can probably find that I think that's probably one of the easy problems to solve, because it should be on a manuscript somewhere, because that's usually like the easiest solution. Every even number is divisible by 2, and then the prime gaps also make it kind of hard to make it, it's kind of like too infinite. I forgot the word. um um See, the prime gaps are infinite. You can't really prove that there are not going to be primes, because there's a number, because you have like in natural numbers you have like a 50% chance of the numbers being even and the 50% chance of the odd numbers being odd. But then the primes uh keep keep decreasing. Prime numbers keep decreasing depending on the prime gaps. Or if you can perceive that prime numbers will decrease because of the prime gaps, and the prime gaps are mostly depending on the multiple of primes. So as long as the prime numbers keep showing up, it's going to keep adding prime gaps. And I think those are probably the two main solutions for the twin prime conjectures. And then the sums of the even numbers. I mean the sums of primes being even. Maybe I can probably type something, keep it more clear, but and then twin primes. Uh, it is true statement that I believe that twin primes are it is an infinitely fact because uh, uh, primes will inevitably show up, but as the prime gaps increase, the primes will decrease. So mostly because what I tried to explain before is because the multiples of primes. So whenever you whenever you add a new prime, it's gonna add more prime gaps. So and that is pretty much the statement right there. And I'm gonna try to see if I can squeeze in the Fibonacci sequence in another video on the prime gaps as well. But yeah, that is pretty much the cherries that I want to talk about. And then that'll probably be the end. And also Collatz conjectures too. You can probably do a proof, but we're not gonna be teaching. We don't really teach math. That'll be another video right there. We don't really teach math like geometry, calculus, all that stuff, all that doctrine. The teachers try to teach you. Yeah, we're not teaching that, so it's not gonna be like fancy proof written or anything like that. Or for those people, they're like, how do you compare this guy to this guy? If this guy writes up like really nice proper proof, and you're like, yeah, it's not really what I'm trying to actually do. But you can go. I mean, it would take actually a couple hours just to 5 more minutes than a YouTube short. So I'm trying to keep everything between probably like 30 minutes to 5 minutes though. And then yeah, so that was pretty much all the cherries, highlights, and whatever you think of the problem. Hopefully it's becomes apparent to what the actual solutions are. So just to recap, all sums of primes, all sums of primes will equal an even number, and all the even numbers will equal sums of primes, and that is probably going to be mostly because of the number 2. Yep. See, because the number 2 can just add itself and create more even numbers. So that particular statement will always be true because of 2, the number 2. So it's infinitely, because natural numbers you can divide. Natural numbers are infinite, but if you take out the 2 infinites, like there's like bigger, smaller infinites, but odd and even numbers are kind of like 50% infinite to one another. So if you can infinitely divide infinity, it will equal into 2 equal parts. There would be even and odds. So and in the even section, it is infinitely true that prime numbers will be the products. If you sum up prime numbers, it will be the products of even numbers because of the number 2, and it will always be a true statement regardless of the position of the even number, because you will always be able to just add 2 if you can't have traditional primes. So, and that particular statement is mostly true due to the prime gaps increasing due to the amount of due to the multiples of primes and prime gaps. And that's it. Adios. And maybe next time I'll do a recap on all the videos. Adios.